Hello, and welcome to the video series on the Tour of Go exercise walkthroughs. Today's video covers the sixth exercise, error, from the Methods and Interfaces module inside of the Methods and Interfaces chapter. Rather than just showing you my solution directly, I'll explain all the necessary Golang concepts and context for you to impart with a deep understanding of what each and every single line of code really means. This exercise is a spin on the first exercise, loops and functions, where we implemented a square root approximation function. We will reuse large parts of this code to solve our errors exercise. The twist is that we'll be returning an error if a negative argument is provided to the function. The starter code is similar to the first exercise. The main difference is that the square root function now returns a second argument of type error. What actually is this error type? We can check the Go programming language specification and go down to errors. The pre-declared type error is defined as an interface with a single method error, which returns a string. It is the conventional interface for representing an error condition with the nil value representing no error. So going back to our errors exercise, the function definition states that we'll be returning a value conforming to the error interface as the second return value. In the main function, there are just two function calls to square root, passing in +2 and -2, and both of these results are printed to standard out. To get started, I reused our previous work from exercise 1 to compute the square root. I simplified the code slightly. To summarize, it initializes z as a starting approximation. In an infinite loop, it stores the previous value of z to track changes between iterations, updates z, checks for convergence against a small tolerance, and if the change between iterations is small enough, z is returned. Now, on this happy path, we'll return nil as the error value. We can test that this works for a positive or converging square root. So let's get rid of this negative case. Run. And we're missing the math package, so we can simply format. We'll add the import and now run. And there we go. It computed the square root of 2, or the approximation. Now let's see what happens for -2. Timeout running the program. The reason the program times out is because Newton's method doesn't converge for negative numbers, and the program gets stuck in an infinite loop. Let's implement the custom error type and return it in case of a negative provided x argument. We can copy over the type definition, or negative square root, which is simply a type alias to float64. And let's also grab the error method to make it an error, or conform to the error interface. And we'll implement the method by returning a properly formatted error message using fump.sprintf. So okay, now that we have created our custom error, let's use it inside of the square root function. If x is less than 0, we'll return 0 as the first value and negative. Okay, let's run this. It works. We've made square root robust by dealing with bad inputs. You might be wondering why we wrapped e as a float64 inside of the error method. The description tells us that we'd otherwise be causing a stack overflow error. So if we remove the type conversion and run it as such, we see no output. Well, fump.sprintf automatically calls the error method or string method if they exist on the receiver argument when replacing the format verb %v. Since e has a method error, it continuously invokes itself, creating that infinite loop. Because this recurses indefinitely, the Tour of Go environment stops the program before anything is printed. However, if you ran this code locally, you'd see the program crash with a stack overflow error. It's common in Go for functions that can fail to have multiple returns where the last return value is the potential error. By convention, when there is an error or the error is not nil, the other values of the multiple return should take their zero value form. So in our case, we are returning a float 64 as 0 when there is an error. According to Rob Pike's 15 Go proverbs, which is a talk I highly recommend watching, first, errors are values, and second, don't just check errors, handle them gracefully. Let's take these proverbs to heart and write some error handling code. So let's remove the print line statement, and we'll get s error. We'll check if error is not equal to nil. And if there's an error, let's simply print it out. And then return. So if there's no error, we can simply print out the square root. And there we go. For a negative square root, we get the error value. And for a positive square root or a positive number, we get the actual approximation. This pattern, error is not equal to nil, is a very common pattern in Go. And at first it seems as though Go code is littered with this error checking and it's excessively verbose, but it really makes sure we handle our errors explicitly. That's it for this one. Hopefully you've gotten something out of this walkthrough. Thank you so much for watching, and I'll see you in the next one. Peace.